Very warm welcome to the Sheldonian. It is very good to see so many of you here and to realize that we didn't have to do what we did last time we invited Nick to Oxford 2 years ago, which is when we had to turn away 400 people, which was embarrassing at the time. But thanks to you all for coming, and thanks to you, Nick, for agreeing to give this lecture on the economics of climate change and the challenges of the future. The 21st Century School exists in order to bring the best minds together to work on the toughest challenges of the future. And our talk tonight exemplifies the nature of these challenges and the nature of the insights that need to be brought to them. It's about excellence and action-oriented academia, and I can think of no better person that has these two attributes than Nick. This is the sixth in our series of distinguished lectures, which Nick gave the first one of in February 2007. We've had over 200,000 downloads on iTunes U on these lectures, and I encourage you to turn your mobile phones off unless you want to resonate around the world. The 21st Century School currently has 15 institutes, embracing about 200 scholars clustered into 15 institutes. We work on the frontiers of health, on major social and technological challenges confronting humanity, and on the environment and climate change. 4 institutes work on the science of climate change, notably on oceans, on tropical forests, on energy and transport. Others, such as the Institute of Science, Innovation and Society and the International Migration Institute, work on some strands of climate change. So it is a very important theme to us, and it's certainly one which we look forward to continuing insights on and continuing growth in terms of our ability to do more work in the school. Nick is known as Mr. Climate Change, or should I say, Lord Climate Change. He's the leading and best-known economist working in this area, and at a time when many are skeptical about the ability of economists to provide insights and to change policy, Nick is a great saviour to us that call ourselves economists, because he's able to show that penetrating economic insights can make enormous difference to the way we think about global challenges. Nick's success in changing minds and policy on climate change goes beyond the power of the arguments in this current work. It is based on over 30 years of deep work in economics that has informed policy across many areas. Generations of former collaborators, students and friends now seek his counsel. These range from the leaders of China, India and Whitehall to those that continue to plough the furrows of academia or farmers' fields. The 21st Century School is fortunate that he's also giving us his counsel by being on his advisory council. And indeed, I'm here tonight due to the counsel he gave me personally to take this job, for which I'm immensely grateful. Best job in the world. Nick's piercing intellect and engagement in policy reform is combined with a remarkable humility. This is the rarest of attributes in all people, but not least in people with title and distinction as grand as his. His humility is reflected in his wide-ranging interests and his enduring support for many causes, some of them lost, like Wimbledon FC. Professor Lord Nick Stern is a man of many deserved distinctions, including his knighthood awarded for services to economics in 2004. This was before the Stern Review on climate change, and even before he had completed the Commission of Africa. That provided the basis for the Gleneagles Summit in 2005. At the time, Nick was head of the UK Government Economic Service and the second Permanent Secretary. Before joining the UK government, Nick was the chief economist and senior vice president at the World Bank, and before that, chief economist at the EBRD. Long before Nick's contributions on climate change, he made major contributions in many other areas. His first work was with tea farmers in Kenya, and then he lived in a village in India for 8 months, writing a book on the experience. Among the many subsequent books he wrote, his work on tax policy was one that I read as a student, and his many books on development inform development practitioners today. Nick's hallmark, of course, is judgment, and this was displayed from a very young age. He left Cambridge, where he did his undergraduate degree, to come to Oxford. We all know that's a sign of great judgment. He did a doctorate here, and then spent 7 years here as a lecturer before going on to be a professor at Warwick and then at LSE. After leaving academia for international and national civil service, he returned to LSE in 2007 as the I.G. Patel Chair within the India Observatory. Although he sits within the Asia part of the LSE, he is also the Grantham Chair on Climate Change. And his focus since 2005 has been in this area. The Stern Report, which you'll all be familiar with, has galvanized public opinion, and it's contributed to very significant changes in many governments. While Nick's previous talk at the school was about the principal conclusions of that report, today's talk will take us to the next steps. What can global society and government do to ensure that we come to a solution which will bring about a mitigation of the threat of climate change? This draws on his new book, A Blueprint for a Safer Future, which Blackwells will have signed copies of immediately after this lecture until 7:30. Nick's gift is his ability to combine deep economic insight with a similarly deep concern for ordinary people and for our planet. This is exemplified in his work on climate change. It's with great joy that I invite him to the podium.
Thank you very much, Ian. That was very kind. And you do indeed have certainly the best job in Oxford and probably in many other places as well. And it's a privilege to be on the advisory council of the James Martin School. A wonderful creation, and I'm sorry, we see James from time to time. I know he can't be with us today, but I'd like to express my gratitude to him for what he did in this foundation in Oxford, a university to which I still have very warm feelings. I had 10 very happy years here. I can see some of my closest friends from that time in the hall, and I think they're still friends. We'll find out afterwards. It's a special place for me. When I last spoke to an audience here 2 years ago, I was still a member of Her Majesty's government. I left Her Majesty's, I better rephrase that, I was still a member of Her Majesty's Civil Service, and I left in June of 2007, so I'm in a very happy position of being able to use whatever language that I like to use. Well, I have to say, when I was a civil servant, the powers that be were not difficult at all in letting me pursue whatever I wanted to in terms of where the ideas on climate change were leading me. But I can actually sort of make odd remarks about the previous President of the United States in a much more relaxed way than I was able to do at the time. Now, what I want to do today is to move on from the basic story of the Stern Review, which was that action in this area was urgent and had enormously high returns compared to doing too little, or compared to doing not very much now but more later. Whichever way you looked at it, this was an urgent problem for action, and delay was very costly. That was the basic argument of the first part of the Stern Review, and looking back, I think we underdid the story. I think it actually looks more risky now, given the way in which the science has come through still more strongly over these last 2 or 3 years. Emissions are increasing faster than we thought. The absorptive power of the planet is less than we thought, and some of the manifestations are coming through faster than we thought. So the argument that strong, timely action makes great economic sense is surely much more powerful, even more powerful now, given what we now know and understand, than it was then. But what I want to do is to focus on how we react as a world. It'll have to be a global collaboration on a scale and depth which has never been seen before. It'll have to be a global collaboration which looks forward and anticipates the problem. Now that's quite difficult for human beings. If you look back to circumstances under which we did start to collaborate and create institutions for collaboration at the end of the Second World War, We'd just seen 30 years of 2 world wars and a Great Depression. It was surely obvious, and indeed it was obvious then, there were bodies everywhere. It was clear what came from the inability to collaborate and bad economic policies. This one is more difficult in terms of the strength of the collaborations that is necessary and that we have to anticipate. These problems are going to come with great severity 40, 50, 100, 150 years from now. Many of them, of course, coming through already. But the most severe manifestation of those problems will be a good few decades down the track. They would give us problems much more severe than the 2 wars and the Great Depression. I'll argue that case in just a minute. But we have to anticipate them. So there's a tremendous challenge there. There's no evolutionary biology of ethics and behaviour that can do this for us in a very direct way. It has to be very indirect through the ability that is evolved to anticipate. But there's nothing there that tells us that putting your hand in a pot of boiling water is a bad idea because you get scalded. You've got to anticipate without the direct experience. That's a great test for our rationality as human beings, our forward thinking and our ability to collaborate. There are some signs that we just may pass that test. There are other signs that we may not. And what we do over these coming months will be extremely important to the kind of world that our children and grandchildren live in. And indeed, the younger ones amongst you, the kind of world that you live in. Now, I was told that this is not a good place for slides, and it's clearly not a good place for slides. So what I'm going to do is to appeal to your facility to do mental arithmetic. It's not hard. Multiplication and addition primarily, maybe one bit of division and no subtraction, so you needn't worry too much. But the basic numbers do count, and I want to base my description of the global deal on those basic numbers, and that's why I want to do it that way. Underneath what I'm saying is a lot of quite difficult economics. This is a problem with long lags, it's a problem with lots of uncertainties, it's a problem which, with processes which, many of which will not be in equilibrium. All kinds of technical difficulties in economics underlying all this, and those of you who are economists here will recognise, and indeed have already recognised, and many of you have already worked on them. But the majority are not economists, I take it, so I'm going to try to be accessible to non-economists. I do note, however, that it is your fault. You did have choices that you could have taken, and you didn't. Now, and I was not going to mention AFC Wimbledon. I have to respond because, and my family always tell me I should never do this, but I was provoked. I would like to draw your attention in to the fact that AFC Wimbledon have just won promotion to the conference, the 4th promotion in 7 years, the greatest event in the history of British football. I won't talk about football anymore. The 2 great problems of the 21st century are overcoming world poverty and managing climate change, and we'll succeed or fail on those 2 problems together. They're the defining issues of our century. If we fail to manage climate change, we'll create a physical environment that's so hostile that we will reverse the advances in development that we have seen and make future advances almost impossible. The scale of the phenomena we're talking about are just of that magnitude. On the other hand, if we try to manage climate change by putting obstacles in the way of the ability of developing countries over these next 2 or 3 decades to work to overcome their poverty, we will not build the international coalition that we must build if we're to tackle climate change successfully. We have to see those 2 as intertwined, and indeed it's because of my interest in development really that I was brought in some ways to this story, and it's the implications for development and the poorest countries in the world that I find particularly worrying. But we'll all get hit badly by climate change, rich world or poor world, if we fail to manage it. So I'm not going to emphasise the development story all the way through what I have to say, but I did want to underline it very strongly at the beginning, and I'll come back to it at a few points in what I have to say. The village of Palanpur in UP, where I've been working now for 35 years with friends and collaborators, is the kind of place that would be hit particularly hard. When we first went there, the water table was about 10 or 12 feet down. It's now about 40 and going on falling. Part of that, no doubt, is related to the increased runoff as the rivers and rainfall change as a result of climate change. Other parts of it because they don't price water properly, and what's going on is water mining, but that's another part of the story. So we must remember right through that this is a challenge for managing climate change and for economic development. Many of you will also have noticed that we have an economic crisis going on. To the rest, right at the end of this, I'll try to say a few words about the relationship between the planetary and much more severe and long-lasting crisis and the economic crisis. Now, the story I want to tell is one of a global deal, but it depends intimately on the basic structure of the underlying science and the basic numbers associated with the science. So in building the story of the global deal, I'll start with the science, but I'll tell it in a way that feeds directly into economic policy. I'm not a scientist, I'm a consumer of science, and I try to get advice from the highest authorities in the land and in the world, and the first thing I did when I was asked to do the Stone Review was to sit down and talk with the leading scientists and try to read the science. But I'm not a scientist. I might have done maths and physics as an undergraduate 40 years ago, but that does not make you a scientist. Neither does, of course, the training in the law and in pulling pints and cutting hair make you a scientist either, although superannuated lawyers, people who drive taxis, people who cut hair, all of whom are entirely worthy, but nevertheless are not experts on climate change. They think that they are. And it's very important, I think, to be a consumer of the science and try to understand what the science is telling us. To cross-question from the point of view of policy making, which you have to do. But basically, let me tell the scientific story in a way which fits with the story of economic policy. It starts with people and ends with people. People emit greenhouse gases through their activities of consumption, production, the way they live. They emit greenhouse gases to a degree which is above, to an extent which is above what the Earth can absorb. So the stock of greenhouse gases goes up. This is fundamental here, it's a flow stock problem. The stock of greenhouse gases goes up, it's the greenhouse gases that catch the infrared energy that cause the global warming, those greenhouse gases cause the global warming, so the temperature of the Earth goes up. That's the next step in the chain. The next step in the chain is from global warming to climate change. Global warming doesn't really capture what we're talking about. This is climate change. It's climate and it's change. And it manifests itself from the point of view of human activity, mostly through water in some shape or form. Storms, floods, droughts, sea level rise. This isn't the difference between Stockholm and Madrid. That may be quite substantial from the point of view of temperature. What we're talking about is the rewriting through the increasing temperature and the change in the climate of where we can live and how we can live. It's about rewriting the physical geography and therefore the human geography of the world. So the last step in that chain of causation is from the climate change to people, back to people and what they can do and how they can live. Now, as I've already argued, the first couple of links in that chain look more worrying than many people thought 2 or 3 years ago. Emissions are increasing faster than we thought, absorptive power of the planet less than we thought. That's why I think we understated the risks in the Stern Review. But that's the basic story, and that structure of the science tells us a great deal about the kind of economics we should bring to bear. First, it's a flow stock problem. So delay is dangerous. Flows go into stocks and stocks rise. So this isn't like the World Trade Organization, where if we make a mess of it, as we often do, we can reconvene 5 years later roughly where we were before. If it happens in climate change, 5 or 10 years down the track means considerable increase in the concentrations of greenhouse gases and leave us in a worse starting point. That flow stock problem is fundamental to this story. So basically, it's a flow stock problem. It's a global problem. It doesn't matter whether greenhouse gases are emitted, whether it's Johannesburg or London or Beijing or Los Angeles, they have the same effect. It's a global problem. It's a problem with long lags. These links in the chain that I described are links which, each of which takes some time to manifest itself, sometimes with quite long lags. So the lags in the system are important. The scale of the issue is very important, much bigger than the normal worries we have about so-called externalities, which are the kind of sooty air or congestion in roads. Those are problems which manifest themselves locally and quickly, and you can see what's doing it. This one is much more difficult. It's a global phenomenon. It's got long time lags. The scale after those time lags is potentially very big, and there are lots of uncertainty. So this is actually a kind of interrelationship between what we do and what others can do of a much more complicated and difficult kind than we normally deal with in economics. It's clear then that any discussion of policy has got to be about risk and the management of risk. Any discussion of policy has got to be global. It's global in its origins and global in its effects. Any discussion of policy has got to take intertemporal issues, the relationship between one generation and the next very seriously, and it's got to take distribution issues at any given moment in time very seriously, because it's poor countries that are hit earliest and hardest by this problem. So you can see it is very different from the kinds of problems that we traditionally talk about in economics, which are based on marginal comparisons. Marginal means small perturbations, small pluses or minuses around some given story or around some given growth path. This is a very different problem from that. We do have the tools of economics, many of them at least, not all of them, but we have many of the tools of economics capable of dealing with the problem I've just described. But the simple-minded tax on an externality, which is what we teach our second-year students, is only the beginning of the discussion. We have to go, for the reasons I described, way beyond that story when we bring our analytical tools to bear. It's the magnitude of the effect and the degree of uncertainty which lies behind the mistakes, I believe, that many, far from all, but many of the early economic analyses perpetrated. They didn't take on board just how big this problem was. It was modelled as a growth path and climate change giving a bit of a perturbation from a growth path. That has to be the wrong way to look at a question which is determining future standards of living on a massive scale by the actions which we now take. What we do, what policies we make now, determine whether we're likely to grow in the future, whether the world is plunged into conflict or not. So you cannot bring the ordinary marginal techniques of economics to bear. Once that is clear, much of the rest of the analysis from the economist's point of view follows through in a fairly natural way, and that's what I'll try to describe. But I think economics as a whole, although there were some very notable and important exceptions, didn't deal with this problem as a problem of massive scale and huge uncertainty and risk. And that's what it is in large measure is about. Now, let me turn to some of the basic arithmetic which underpins the story of the global deal, which I want to tell. We start in a bad place. We start at 430 something, perhaps 435 parts per million, maybe a bit more, of CO2 equivalent in the atmosphere. That CO2, 380 plus, together with 50 parts per million of CO2 equivalent, the contribution of the other gases in equivalent terms to CO2, equivalent in terms of their global warming effect. So we are about 435 parts per million. We're adding about 2.5 parts per million a year, and that 2.5 parts per million we're adding each year is rising. So where would we be if we did not much for 100 years? Well, we'd probably average somewhere well over 3 parts per million added per year over a century of business as usual. So if you added 300 or so, or more, to 435, 300 is 3 times 100, you got that? That would take us to something around 750. What would that mean? Suppose we stopped it right there, and the probabilities I'm about to quote come from the Hadley Centre, which is a fine climate meteorological research centre in Exeter. And we work closely with them in preparing the Stern Review, and I still talk to them a lot and I'm full of admiration for what they do. But the numbers that they give are not so very different from the numbers other people give, and indeed they're probably quite sort of moderate and modest and leave out quite a lot of worrying things, which they recognise very readily and explain. So suppose we did hold it right there at 750 parts per million. What would be the probabilities of different kinds of temperature increases? It's about probabilities, we can't say it for certain, but what the science has been able to do for us in the last 10 or 15 years is start to tell us about probabilities. Prior to that, there were ranges and possibilities of different kinds of outcomes, but what we've now got is an assessment, for better or for worse, but I think on the whole for better, of probabilities. What would it mean? It would mean a probability of roughly 50-50 of being above 5 degrees centigrade relative to pre-industrial time. So when I talk about temperature increases, I'm talking mostly about comparisons with the time in question and, say, 1850. 5 degrees centigrade above pre-industrial times. Well, 5 degrees centigrade may not sound very much if you're in Moscow in February, but it is truly enormous. A 5 degrees centigrade above pre-industrial times we have not seen as a world as a planet, I should say, for around 30 million years or more. Human beings have been around, well, it depends on how tight your definition of sapiens is in Homo sapiens, but human beings probably around 100,000, maybe 200,000 years. That's their lifetimes, our lifetimes as humans, are tiny compared to the distance in time since we've seen that kind of temperature. The world was mostly covered in swampy forests, it seems, at that time. Very little or no ice. We've been 5 degrees centigrade less comparatively recently and comparatively often. The last ice age, 10 or 12,000 years ago, was orders of magnitude 5 degrees centigrade less than the middle of the 19th century. The ice sheets came down to latitudes of, in an English audience you can refer to Watford, other places you have to talk about London. But the ice sheets came down, and Watford always gets a laugh. Is there anybody here from Watford? Yeah. Good for you. But what point am I making here? It affects profoundly where people can be and where people can live. There were people around, of course, 10, 12,000 years ago, relatively few relative to now, but there were, and they were closer to the equator than Watford, with good reason, because of the ice. This transforms where people can be. You know, when it melted, the UK separated from France, and maybe good thing, bad thing, but it's profound change. This is changing the physical geography of the world in a profound way. This would redraw where the rivers flowed. It would redraw where many coasts were. Southern Europe would probably look like the Sahara. Other parts of the world would be so battered by hurricanes it wouldn't make any sense to be there. This redraws where people can be. This is a huge, huge change. We can't describe it very well because we can't describe how humans would fare in that kind of environment because they've never seen anything like it, not remotely. 2 or 3 million years ago, since we were 3 degrees centigrade higher. The idea that you could sort of wear a fairly flexible, adaptable lot and we'll just adapt to it when it comes along, you know, maybe wear lighter clothing and bigger hats and all that sort of thing, is just not credible relative to the kind of change that we're talking about. Of course we'll adapt. I mean, some people will have to swim, but the challenge of adaptation in this kind of scale is just out of all imagination relative to the kind of thing that we've seen. Now, what if we held it? I could have told the story at 4 degrees, 6 degrees, 7 degrees. No, we should be talking about the whole distribution of temperatures here, but just to keep it fixed and because I haven't got any slides. I'm talking about 5 degrees centigrade, but it makes the point. What could we do? Well, we can hold it below 500 parts per million. We can't hold it below 450. We'll be at 450 in 6 years, maybe 5 years. This is the kind of thing in which prediction is fairly easy. We are at 435, we're adding 2.5 a year. That's 6 times 2.5 is 15, 15 and 435 is 450. That's where we're going to be very quickly, right? But we could hold it below 500 with good policy, and then we should be thinking about how to bring it on down from there. And we are starting to think about how to bring things down. Of course, if you drop emissions low enough, at some point you'll get below the world will be able, the planet will be able to absorb more than that, but that's quite a long way off. So we're going to have to think about how to get greenhouse gases out of the atmosphere. But what we can't do is bet the future of the planet on our ability to do that fast or effectively. What we have to do is think about reducing the emissions. So we could hold it below 500 parts per million. What do we get for that? Well, that probability of about a half of going above 5 degrees centigrade would drop to around 3%. Now, I don't know whether the probability of a half should be a probability of 40% or a probability of 60%. I don't know whether the 3% probability I'm talking about should be 1% or 5%. But what we can see is we get a massive reduction of the probability going to a very dangerous place. Now, what would that cost us? Because it sounds like a very attractive insurance policy, but you've got to check what the premium might be. Well, in order to hold below 500 parts per million, we'd have to cut emissions down to about 20 gigatons of CO2 equivalent or below by 2050. We were, in 1990, fairly close to that in 2000, around 40 gigatons CO2 equivalent. So relative to 1990, we'd have to cut global emissions by 50% at least. Now there's a very powerful scientific case for cutting much more than that. But let me speak for the moment about holding below 500 and cutting emissions by 50% relative to 1990. Now, economists and politicians play sort of fancy footwork and slightly devious about percentages and starting points and all that. But just fix on the 20 gigatons in 2050. Whatever we decide to do as a world, whatever one country says it's going to do, we've got to get below that, 20 gigatons. Now, wherever you go, and I've travelled too much in the last 2 years, people put their arms around you and say, Nick, we like you very much, but you don't understand that Canada is different, or Russia is different, or South Africa is different. Other people, sure, they can do these things, but it's just a bit too difficult for us. Well, you know, the climate doesn't negotiate. If you got to get below 20 gigatons, it's what the adding up of what everybody emits has got to fit with that. But what does it mean in terms of taking out emissions from what we might otherwise have done? Economists are quite good at what we might otherwise have done, can't be checked. But business as usual might look, because we're over 50 gigatons now, business as usual might look like emissions of, say, 85 in 2050. So I'm not being heavy about it. I'm saying it's a good bit less than doubling by 2050 under business as usual. 85 compared to 20, here's a subtraction, 65. What would it cost us? Now, some part of this has negative cost, energy efficiency. Other parts could be quite expensive. There'll be some kind of gradient of cost going from negative to quite expensive. And we can work on the detail, work on the models, many people have, but let me take $30 a tonne as an average over this 65. Well, 65 gigatons, remembering that giga is the same as billion, scientists like giga, economists like billion, 65 billion times $30. Well, 3 times 6.5 is easy, right? But you've got to get your noughts in the right place. If you do this sum and put your noughts in the right place, you get 1.95 trillion. 2 trillion, given the kind of error range in which we're talking about here. GDP of the world in 2050, if we follow good policies, including on climate, could be about double where we are now. We are a bit over 50 trillion. Now it depends which year's prices you use and so on. I'm not fussing about that, given the kind of sum that we're doing. So if we doubled from a bit over 50, we'd be a bit over 100. That makes percentages easy. So 2 trillion and 100 some trillion, around 2%. So that's the kind of order of magnitude. Primary energy is in the modern economy 3-4% of GDP. Suppose our actions essentially put the cost of that up by 50%. I think actually on average it could be less than that. Again, you're coming in with numbers, you know, if you have a 50% increase in 4%, that's 2%. So these are the kinds of numbers that many people have come up with. I think it actually makes a fair amount of allowance for bad policy. And, you know, you have to, because policy isn't always brilliant. But because other people looking at sort of more optimised policies, a difficult concept in this context, but other people looking at sort of strongly good policies have come up with numbers quite a bit lower than that 2% that I've described. So you can tell then roughly what the insurance premium is. You know, 2%, my guess is it will be a good bit less because we'll be learning like mad along the way. For the kind of reduction in the probability of catastrophe that I've just described, I mean, it's a no-brainer, I think, to most people. But actually, the return to this investment is even better than that. It is, if we adopt a green recovery in an intelligent way, it will help us get out of the recession in the coming months and years. If we look forward to the next 2 or 3 decades, this is going to be the Schumpeterian growth story, the low-carbon technologies. It'll be like the railways, it'll be like electricity, it will be like IT. That's the kind of change that we can see in the way in which the economies grow. So this is a policy which could have, if well designed, good returns in terms of a recession. It's a policy which will likely move us into a Schumpeterian period of growth. When we achieve low carbon growth, it will be cleaner in the normal sense of clean, without the sort of much sooty stuff in the atmosphere. It will be more energy secure. It'll probably be quieter, safer, and more biodiverse. So here you are. You've got a policy which has got good returns in the very short run, likely to put you onto a Schumpeterian period of a growth surge based on innovation and technology, takes you to a much cleaner, more attractive form of growth, and of course allows growth to continue, at least for a while. Because high carbon growth kills itself, first on very high prices for hydrocarbons, and secondly on a very hostile environment that it creates. All this for 1 or 2% of GDP for a few decades? I mean, it really is hard to see why we shouldn't do this. Problem is, of course, we have to collaborate to do this, and that takes me to the global deal. Now, 20 gigatons, 20 billion tons of CO2 equivalent in 2050, 9 billion people. There will be around 9 billion people in 2050. 20 divided by 9 is just over 2. That was easy, but it won't be easy to get there. The United States, Canada, Australia, over 20 tons per capita. Europe, Japan, 10, 12 tons per capita. China, already over 5 tons per capita. And India, under 2 tons per capita, but growing quickly. Much of sub-Saharan Africa, around or less than 1 ton per capita. Now, there won't be many people below 2 tons per capita in 2050, because there will be growth in countries which, at least we trust there will be, in countries that are currently poor. So there won't be many people below 2 tons per capita. So here's a bit of obvious number crunching, which you can immediately see. If the average is 2, and there are not many people below 2, there can't be many people above 2. The average is the average. Now this isn't Lake Wobegon, where all the men are beautiful, all the women strong, and all the children are above average. I hope you all read Garrison Keillor. The average is the average. So if there are not many people below 2, there can't be many people above 2. So in terms of actual emissions, we've got to get down to 2. So for rich countries, let's take Europe and Japan as examples, dividing by 5, taking their 10 or 12 tons per capita down to 2, is, roughly speaking, in terms of actual emissions where they have to go, that's 80% reductions. So when we talk in the G7 in Heiligendamm 2 years ago, and last year, that was in Germany, and in Hokkaido in Japan last year, when we talk about 50% reductions by 2050, we're getting roughly in the right ballpark for the planet. When we in the UK now committed to 80% reductions by 2050, we're talking about the right kinds of numbers. France has had its factor 4 for 5 years now. Well, dividing by 4, but they got in 5 years ago, so that's close enough to dividing by 5. Barack Obama has declared for 80% reductions 1990 to 2050, dividing by 5 again. Now, those of you who are ahead of me will have noticed that 20-something divided by 5 is around 4, not around 2. So we have to assume that President Obama made a slight slip of the tongue, and what he meant to say was 90% reductions by 2050. But basically, the important thing here is to set off strongly in a good direction. We'll discover a lot along the way, we'll learn a lot along the way. I don't see any point in arm wrestling about whether President Obama should have said 90% rather than 80%, which he did say. We should just celebrate the difference between him and his predecessor. So you can see, at least in political terms, we're talking the right kind of numbers. And I believe that that will be a key part of the agreement. I'm going to run through the global agreement now pretty fast, but I've just given the first and strongest part of the global agreement. At least 50% reductions relative to 1990 for the planet as a whole, and at least 80% reductions for rich countries. If people start getting funny with the percentages and the baselines, just remind them it's got to add up to something less than 20 gigatons. That's the first part of the global deal. This is a global deal that has to be effective, efficient and equitable. Effective has got to get reductions on the right scale. I've said what that is, and they should be at least in front of everything I've said. So it's got to be effective, it's got to be of that magnitude. It's got to be efficient. If we don't do this as cheaply as possible, it'll be very difficult to sustain that global deal, to keep people with you if they see it as wasting a lot of money. And it's got to be equitable if people are going to sign up to the global deal and if it's going to be sustained. The first part of the equity story is that the rich countries should be cutting by at least 80%, 1990 to 2050. Please don't confuse the actual emissions with any quotas of emissions. I do not think the quotas for emissions should be 2 tons per capita for everybody. The rich country is responsible for 60-65% of the concentrations in the atmosphere now. This is a flow stock problem. You can't deal with a flow stock problem by having a party that lasts 200 years, where some people drink much more than others, and then you define equity as all drinking about out of the same size glass on the last day of the party. That's not particularly equitable. But so if we did end up with quotas the same per capita for everybody in 2050, then it's more equitable than some of the things you can imagine, but we shouldn't over-celebrate just how equitable that would be. So when I say actual emissions should be down to 2 tons per capita, it doesn't mean that everybody has an equal right to emit. That's just nonsense. We don't have any right to emit. We have a right to enjoy national parks equally. We have a right to equal access to the commons. We do not have a right, as far as I can see, an equal right to destroy the commons. We can't all take away, 100 weight of earth from the Peak District National Park on the grounds that we've got equal right to own that thing. We're taking our bit home with us. So I think I do want to draw that sharp distinction between the actual emissions and where they'll have to be, which follows simply from the arithmetic I've described, and the allocation of rights, which is a question about the distribution of income, into which lots of things rightly come. But anyway, that's the first part of the global deal. Second part of the global deal on the efficiency front and on the equity front is that we have to have a way of financing the activities of developing countries. It'd be quite wrong to ask them to slow down their development. I don't think we'd get a global deal if we push too hard on that. The challenge is to help finance. And one way of doing that is through carbon trading, where rich countries can buy some of the reductions in poorer countries. It makes economic. You buy your shirts where your shirts are cheaper, you should, keeping costs down, buy the emissions reductions where emissions are cheaper. But it also allows the flows of funds to developing countries, which would be part of the glue that holds this global deal together. That's the second part of the global deal. So let me put together with that, number it 2 or 3, the role of developing countries. Developing countries are preparing climate change action plans. I think their position will be and should be, this is our world, there's 8 billion people in the currently developing countries in 2050, but in the 9 billion altogether. We get hit earliest and hardest. Let us explain to you, rich countries, what the global deal looks like. We know that we're all in this together, we know how vulnerable we are, we've all got to act together. But what we don't want, as we have had in the past, is propositions put by the rich countries and batted back by the poor countries. There has to be a collaborative way of looking at this, and if there's to be any direction of the propositions, it should be from developing countries to developed, explaining what's necessary and the conditions of the deal. Far better, of course, to have everybody getting together and working it out together. But the conditionality of the poor world and the rich world should be, first, you've got to do these 80% reductions. Secondly, you've got technologies. When you develop your technologies, you've got to share them with us. And indeed, we will share our technologies with you. The biggest producer of photovoltaics in the world is in China. Yeah? India has got a very big capacity for producing the equipment for generation by wind. So it's going to be a sharing of the technologies, but we have to have the sharing of the technologies. And the so you have to have finance, you have to have the targets in the rich countries, you have to have the finance through the trading as I described, or some other way, and you have to have the sharing of the technologies. The last aspects of the global deal I mentioned very quickly, and then I'll close because our chairman is indicating that time is going by. Deforestation is responsible for up to 1/5 of the world's emissions, depending on how you do the numbers. We all benefit if deforestation is stopped. Unless deforestation is stopped, we cannot possibly meet the kind of targets that I described. It's for the countries where the trees stand to design the protection of the forests and design their development strategies, one very closely intertwined with the other, but it's the job of everybody else to help with the finance of that change. You won't stop deforestation unless the alternative agricultural activities are more productive. That means agricultural development. It's important there are opportunities outside agriculture too. That means development in general. You're going to have to deal with systems of property rights which involve good governance. The whole story of deforestation and development is inextricably intertwined, and we will fail to stop deforestation unless we see this as part and parcel of the development process, which is shaped by the countries where the trees stand and supported by others. Technological sharing, we're going to need specific schemes for that to happen. And finally, development in a more hostile climate is more costly. We have to recognise that when we were in Monterey and the financing for development, for the Millennium Development Goals in 2002, when we were in Gleneagles and talking about the Commission for Africa in 2005, we did not factor in the extra cost of development associated with climate change. I can tell you that because I was in Monterey when I was Chief Economist of the World Bank, and I wrote the report for the Commission for Africa. I'm as guilty or more guilty as anybody else on that, but we did not factor climate change in. When we look beyond the Millennium Development Goals, we're going to have to recognise that development is more difficult and more costly than we thought it was because of an increasingly hostile climate, even if we act as responsibly as we can from now on. So that's the story of the global deal. It's actually quite simple. You know, it's the objectives, it's the of different kinds of countries, it's the trading, it's the deforestation, it's the sharing of technologies, and it's the funding for adaptation. And it is, and you can fill it in more detail, effective, efficient, and equitable. It is not going to work without the collaboration. The 20 gigatons, suppose that the rich world emitted absolutely zero in 2050. So you're dividing 20 by 8 rather than 20 by 9 billion. The average for the poor countries would have to be 2.5 tonnes per capita. It's not going to work unless everybody comes in, and that's why it's so important that the rich world meets the natural and equitable conditionality that the poor world will impose. So, finally, will we get there? Well, we know the scale of action that's necessary. We know where we have to act: energy efficiency, low carbon technologies. We know what zero carbon electricity looks like, and we can describe lots of ways of doing it. If we've got low carbon electricity, we can have low carbon surface transport, because we can run the cars or whatever off, or public transport, off that zero carbon electricity. So energy efficiency, low carbon technologies, particularly electricity, but across the board, and deforestation. We know what to do. So we know the scale of action required. We know the types of actions we need to take. We can see that it has to be right across the economy. It has to be transport, it has to be electricity, it has to be buildings, and so on. It has to be right across. So we can see what's involved. We can recognise the economic policies that can support this. You obviously have to have a strong disincentive to emit greenhouse gases. You need a price on greenhouse gases. But we're in a hurry and there's lots of uncertainties. We're going to need regulation too. Yeah? And we're going to need support for technologies, because we're in a hurry and technologies can be held back if there's an incentive not to release them. So we need these kinds of policies: price for carbon, regulation, support for technologies. Again, we can fill in much of the detail. So we know the scale of action, we know where to act, we know the economic policies that could do this. What's the problem? Well, it's political will. And I can tell a story, as many people here can, and you do hear them in the saloon bar. It's never going to work, politicians are too short-sighted, they just care about the next election. Or Americans are never going to give up their big cars, and the Russians will cheat, and the Chinese will never agree, and the Brits are too lazy. And you can tell all sorts of barroom stories about why it might not happen. But where does that take you? If you're very negative about the opportunities here, you can be sure that we will fail. Collective pessimism will be on our ability to act, will deliver the inability to act. If that's the line, then at least we should be honest. We can buy a hat and get some suntan lotion and write a letter of apology to our grandchildren and say that, we knew what to do, but, it's difficult and we couldn't get together, and, we were watching football and so on. But surely the right way to look at this is to say, these are the kinds of things we have to do, these are the kind of coalitions that we have to build, and let's get on with it and see if we can get there. Because if we don't, we know we're in very serious trouble. So people have to understand the magnitude of the risk, but also that this story looks quite attractive. It's the story of growth over the next 2 or 3 decades. It's the story of low carbon growth, which looks much more attractive. Now, I don't know if we're going to grow forever, but if we don't grow for the next 2, 3, 4 decades, it'd be very difficult to meet one of the two key defining challenges of our century, which is the overcoming of world poverty. Now, will we grow forever? Probably not. As Woody Allen said, eternity is a long time, particularly near the end. But we are, I think, going to have to grow for 3 or 4 decades. But if we are, as I think we must from the point of view of world poverty, it's crucial that we grow in a clean and sustainable way. I think we can see how to do that. So the challenge now, and it involves all of us, is to bring about, or work to bring about, the political coalition for action that we need. Thank you very much.